Hello, wonderful students. You're welcome to class. Yes, this is Maths with Mr. Olukorede. I'm excited having you here, and I'm happy that you guys are there. Now, today we want to look at some questions under indices. So we are going to be looking at some tough questions that most students run away from. But honestly, they are not hard. So all we just need to know is the trick behind the solution to the problem. Okay, so we are going to learn all of those things in today's class. So I want you to get yourself ready for today's class. Invite your friends, let them know the class is about commencing. So I want you to look at the problems we have here. All right, so before we solve the problem together, if you can lay your hands on any of the questions, okay? So try and let's see what you're going to have. So by the time we solve the problem together, so we see whether you know how to solve the problem or not. All right, so kindly invite your friends. And I also want to say this, if you are just seeing me for the first time, all right, this video, in this video, what we do here is mathematics. We make fun with mathematics. So if you are interested in what we are doing here, I want you to subscribe to this channel, and also don't forget to drop your thoughts. All right. Okay, so let us wait for others to join. Okay, yes, let's solve the problem we have here. Now the question asks you to simplify the following. So we have 2 raised to the power of 3x times 8 raised to the power of x minus 1 all over 4 raised to the power of x. Now let's write the question out. Now we have 2 raised to the power of 3x times 8 raised to the power of x minus 1 all over 4 raised to the power of x. Now, how do you simplify this problem? Now, the first thing is to express each of these terms such that they have the same base. Now, 4 is the multiple of 2. Okay, 4 is the same thing as 2 raised to the power of 2, while 8 is also the same thing as 2 raised to the power of 3. Right, so now let's write this expression as 2 raised to the power of 3x times 2 raised to the power of 3 times x minus 1, everything all over 2 raised to the power of 2x. Okay, now we are going to be applying one of the laws of indices here. Whenever you have x raised to the power of m raised to the power of n, now the powers will multiply each other. So we'll be having x raised to the power of m times n. All right. So in this case here, m is 3 and n is x minus 1. Also here, m is 2 while n is what? X. All right. Now this expression turns to 2 raised to the power of 3x times 2 raised to the power. So we use 3 to multiply each of the terms inside the bracket. So 3 times x, that is 3x. 3 times negative 1, we have negative 3. Everything all over 2 raised to the power of 2x. Okay, so now the next thing is to apply 2 laws of indices. Now the first one is law of multiplication. So whenever you have x raised to the power of m times x raised to the power of n, the result is x raised to the power of m plus n. You just add the powers together, provided the base is the same. All right. So another one is x raised to the power of m divided by x raised to the power of n. the result is x raised to the power of m minus n. You understand? If the base is the same, you subtract the power. So law of division, and this is law of multiplication. All right. So now this expression turns to, now we are applying law of multiplication here. So that's going to be what? 2 raised to the power of 3x plus, okay? Since the base is the same thing, you had the powers. So you have 3x minus 3. Okay, everything all over 2 raised to the power of 2x. All right, now let's tidy up what we have at the top here. So we have 2 raised to the power of 6x. 3x plus 3x, that is 6x minus 3, all over 2 raised to the power of 2x. Now, the next thing is to apply law of division. So when dividing, we subtract the powers. So now we have 2 raised to the power of 6x minus 3 minus 2x. So our final answer is 2 raised to the power of, now you subtract 2x from 6x. So what do we have? We have 4x minus 3. Okay, so that is what we have as the answer. So 2 raised to the power of 4x minus 3. Okay, so I hope you understand the procedure. Okay, so now let's move down to the second one. Let's move down to second one. And don't forget, if you are just joining, don't forget to share the link, invite your friends, let them know the class have started. Okay, all right. So the second question we have here, let's look at it. We have 3 raised to the power of x plus 2 plus 3 raised to the power of x plus 1 over 3 raised to the power of x. All right, you have to simplify this initial expression. So how do we simplify this? Now you see, what comes to mind is laws of indices. How will I apply law of indices to solve this brilliantly? All right, now let's look at it. Now I'm going to be applying this law of multiplication. If I have 3 raised to the power of, or let me generalize it, x raised to the power of m times x raised to the power of n. The result is x raised to the power of m plus n. Okay? All right. So look at this term there, 3 raised to the power of x plus 2. I can express this as 3 raised to the power of x times 3 raised to the power of 2. I hope you understand that, because the base is the same thing. So now once you add the powers together, you have this. Now let's look at the second term. Now the second term, 3 raised to the power of x plus 1 can be expressed as 3 raised to the power of x times 3 raised to the power of 1. Okay, I want to believe you understand that. So now, since we know this, we hold. So this expression here, we turn to, the expression here turns to 3 raised to the power of x times 3 raised to the power of 2 plus 3 raised to the power of x, okay, times 3 raised to the power of 1. Everything all over 3 raised to the power of x. I hope you understand that. Okay, so now look at these two terms. This is the first term and the second term. So what's going to be the GCD? I want you to drop the answer in the comment section, because I want this class to be interactive. So now looking at these two terms now, what do you think is going to be the GCD of these two terms? Now I'm asking for the common factor. Okay, so is there anyone dropping the answer there? So what's going to be the GCD of the numerator? So what's the GCD of the numerator? Anyone? right? What's the GCD of the numerator? Okay, so I'm asking for the common term. Common term, okay. Yeah. Yeah, you are welcome, technology, okay, you're welcome. All right. Okay. Anyone? Okay, so yeah. Okay, I don't know. So if you drop your answer, let's see, maybe it's the same thing what we're going to have here. Now the GCD is 3 raised to the power of x. It's 3 raised to the power of x. That's the GCD. It's common to these two terms. All right. So you can factor out this. So we have 3 raised to the power of x. Okay, so when you divide this by 3 raised to the power of x, if you cancel this out, so we'll be left with what? 3 raised to the power of 2 plus 3 raised to the power of 1. Everything all over 3 raised to the power of x. Okay, can you see that now? So you have factored out the GCD. All right, so now this will cancel this. So this cancel this. So what we are left with now is 3 raised to the power of 2 plus 3 raised to the power of 1. And that's the same thing as what? 9 plus 3. Plus 3 times 3 is 9. Okay, so and the final answer is what? 12. That is the answer to the problem. All right, so if you are just joining this class, now what we do here is we make fun with mathematics. We look at relevant questions that that are in mathematics. So like what we have here now, there are questions that many students run away from. Okay, so I've penciled down a lot of problems that we solve here together. And in this class, it's always interactive. So most times I ask questions. So I will always appreciate if you're in the class, you reply to my questions. Okay, so if you are new in this channel and you love what we are doing here, you have not subscribed, so I want you to subscribe, and don't forget to always drop your thoughts, and you tap the like button. Thank you as you do that. Okay, can we move down to the third one, the third question? The third question. Okay, we have x raised to the power of 1 over 2 plus x raised to the power of negative 1 over 2 raised to the power of 2 all over x raised to the power of 1 over 2. All right. So how do we solve this type of problem? So we have to carefully look at the question and ensure that we don't make any method mistake. Okay. Now, many students, when they want to solve this, they will just go ahead and write one single base and add the powers together, applying the law of multiplication, which is not true for this. Now, we have two indicia expression adding themselves, so you cannot apply law of multiplication. All right, so what is the first thing you're going to do? Now, when you examine this, the numerator looks like this: a plus b raised to the power of 2. Okay, so we have, this is different from this. Okay, so we have different terms being added together and raised to the power of 2. Okay, so how do we do this if you are given this type of problem? Now, the result is a squared plus 2ab plus b squared. So that's how, once we expand it, this is what we're going to have. Okay, so now I'm working with this numerator here. So this numerator, in this numerator, a is the same thing as what? A is the same thing as x raised to the power of 1 over 2. While b is x raised to the power of negative 1 over 2. Okay, so now this question, x raised to the power of 1 over 2 plus x raised to the power of negative 1 over 2 raised to the power of 2 over x raised to the power of 1 over 2 is equals to, now I'm going to express this in this form. All right, don't forget this is A and this is B. Okay, so I will express that. So in place of A now, I have x raised to the power of 1 over 2. So I have x raised to the power of 1 over 2 all squared plus 2ab. That is 2 times A times B. We have 2a. What is A? A is x raised to the power of 1 over 2. And B is x raised to the power of negative 1 over 2. All right? Now, plus B squared. So B is x raised to the power of negative 1 over 2. Everything raised to the power of 2. Now, divided by x raised to the power of 1 over 2. Okay, I hope you get that. So, now this turns to, now to simplify this, I have to apply this law of indices. Whenever you have x raised to the power of m raised to the power of n, the result is x raised to the power of m times n. Okay, so these powers will multiply each other. All right, so in that case, this will multiply this. So half times 2. So 2 will cancel 2. So we have 1. So that means this one cancel this. So we have x raised to the power of 1. So that's the first thing we have. X raised to the power of 1. Okay. Now the next one is plus 2 x raised to the power of, now we have two entity multiplying each other with same base. So what we are supposed to do is to add the powers together. All right, don't forget law of multiplication. Whenever you are multiplying two indicial expressions together, you add the power, provided they have same base. All right, now, so these have same base, so we add these together. So we are adding half and negative half. That gives you 0. So half plus negative half, that is 0. So that means what we have here now is x raised to the power of 0. So the multiplication of this and this gives you x raised to the power of 0. Okay, now let's look at the third one, plus x raised to the power of, now you can see we have power of 2 here. Now these 2 will cancel these 2. So we'll be having x raised to the power of negative what? 1. And everything all over x raised to the power of 1 over 2. Okay, so now what is going to be the final answer to this problem? All right, now the final answer now is you use each of these to divide this. We have 3 terms here, 1, 2, 3. So this divides this divides this. Okay, so can we do that now? So now we have x raised to the power of, now don't forget law of division. Whenever you are dividing and we have same base, we subtract the powers. Okay, so this is going to be 1 minus half. So this is 1 over 2, because 1 minus half is half. So we have x raised to the power of 1 minus half. So plus we have 2 raised to the power of x. Now is 0 minus half. 0 minus half is going to give you minus half. 0 minus half, that's minus half. Okay, so now this is raised to the power of minus half. Okay, and the last one plus x raised to the power of, now negative 1 minus 1 over 2. That gives you minus 3 over 2. Okay, hope you know why. When you have negative 1 minus 1 over 2. So that is going to give you minus 1.5. Okay, we have minus 1 and minus half. So that's going to give you minus 1.5. And 1.5 is the same thing as 3 over 2. When you convert this to improper fraction, that's 2 times 1, 2 plus 1, that is 3/2. Okay, so now this is the answer to the problem, right? Okay, so you can see the method and the laws that we apply to solve that problem. All right, so let's move down to another question on the indices. So while I'm writing the question on the board, if you have some of your friends that are not yet on board, you can invite them. Okay, so whatever class you had, this class, the lesson for today is going to be beneficial. So invite your friends, let them join us here. Okay. Okay, now let's look at the next set of questions. All right, you have to solve the following. We have 5 raised to the power of 2x equals to 125 x minus 1, and 2 raised to the power of x plus 2 raised to the power of x plus 1 equals to 48. And the third one is 2 raised to the power of x plus 1 plus 2 raised to the power of x plus 2 raised to the power of x minus 1 equals to 56. All right, so how do you solve this problem? Now let's look at the first one. We have 5 raised to the power of 2x equals to 125 raised to the power of x minus 1. Now what's the first thing to do? Now you look at the two sides of the equation, all right? You ensure that they have the same base. Now you can adjust this such that it's going to have a base of 5. So now 125 is the same thing as what? 5 raised to the power of 3, because 5 times 5 times 5 is 125. So now this equation turns to 5 raised to the power of 2x equals to 5 raised to the power of 3 times x minus 1. All right? Okay, so now since the base here and here are the same, base are the same, you equate the power. So that means the powers too must also be equal. So you now say 2x equals to 3 times x minus 1. All right, so we have 2x equals to 3x. You open the bracket, 3 times x, 3x minus 3. Okay, here you collect the like terms. So you have 2x negative 3x equals to negative 3. So when you subtract, you have negative x equals to negative 3. So multiply negative by both sides. Now say therefore x equals to 3, because this will cancel this out. So that is the answer to the first question. Now let's look at the second question. We have 2 raised to the power of x plus 2 raised to the power of x plus 1 equals to 48. Now, how do you solve this problem? Now, what comes to mind is one of the law of multiplication, that is law of indices, sorry. So law of multiplication, all right? So that's what you're going to apply. So you apply law of multiplication. So what is this saying? When you have x raised to the power of m times x raised to the power of n, the result is x raised to the power of what? M plus n. So when multiplying, you add the powers. Okay. So this left-hand side can be written as x raised to the power of 2 raised to the power of x times 2 raised to the power of 0 plus 2 raised to the power of x times 2 raised to the power of 1 equals to 48. I hope you understand that. All right. Don't forget 2 raised to the power of 0 is the same thing as 1. So it's not changing the fact that we have 2 raised to the power of x. So now, what is the GCD of these two terms? This. What is common to these two terms? That is 2 raised to the power of x. Now, and you are left with what? 2 raised to the power of 0. And that's the same thing as 1 plus 2 raised to the power of 2. That is 2. Okay, equals to 48. All right. So we have 2 raised to the power of x times 3. Okay, equals to 48. So what are you to do now? You divide both sides. You divide both sides by 3. Okay, so you divide this by 3, this by 3. Can we do that? So you have 2 raised to the power of x equals to 48 over 3. And that is the same thing as what? 2 raised to the power of x equals to what? 16. So we have 16. Now you express 16 in index form. So we have 2 raised to the power of x equals to 2 raised to the power of 4. When you multiply 2 4 times, by 4 times, we're going to have 16. So now we have same base. So that means the powers 2 must be equal. So therefore, x equals to 4. So that is the answer to the problem, the second one. Now let's look at the last one, the last question. All right. The last one we have 2 raised to the power of x plus 1 plus 2 raised to the power of x plus 2 raised to the power of x minus 1 equals to 56. So how do we solve this? We are going to use the same law of indices, law of multiplication. Okay, so we find a way of factoring out 2 raised to the power of x. All right, so now this one can be expressed as, let's express the left-hand side. Now we have 2 raised to the power of x times 2 raised to the power of 1. Because when you multiply these together, you add the powers. So it's still going to give you this. So this plus 2 raised to the power of x. Okay, now let's look at the last one here. It's the same thing as 2 raised to the power of x times 2 raised to the power of what? 2 raised to the power of negative 1. Okay, because when you multiply this and this together, we add the powers. Okay, do you understand that? Okay, so that is equals to 56. All right. So now we can factor out. Now look at the three terms. We have this is the second one, and this is the third one. Now let's factor out the common term. That is 2 raised to the power of x. So when you factor that out, so here you are left with 2 raised to the power of 2 and raised to the power of 1. Sorry, 2 raised to the power of 1 plus 1. Okay, when you divide 2 raised to the power of x by 2 raised to the power of x, you have 1. Okay, so plus, now the last one, that is 2 raised to the power of negative 1. Everything equals to 56. Okay, so now let's tidy up what we have here. So this is the same thing as 2 raised to the power of x. Now when you add this and this together, you have 3 plus this same thing as 1 over 2. Okay, equals to 56. All right. So now let's add this and this together. We have 2 raised to the power of x. So when you add together, let's see, 3 plus 1 over 2. We have 2, this is over 1. 1 goes in 2, that is 2. 2 times 3, that's 6, plus 2 goes in 2, that's 1. 1 times 1, that is 1. And that is what? 7 over 2. Okay, so what we have here now is going to be 7 over 2, okay, equals to 56. All right, so that's what we have. Okay, so now what do we do now? We divide both sides by the coefficients of 2 raised to the power of x. All right, so now let's do that. So we have 2 raised to the power of x equals to 56 divided by 7 over 2. Okay, so and that is going to give you 2 raised to the power of x equals to 56 times 2 over 7. All right, so this is 2 raised to the power of x equals to, now let's look at it. 7 goes there 1, 7 goes there is 8. So we have 8 times 2. Okay, so and that is what? 2 raised to the power of 2 of x equals to 16. All right, so now when you express 16 in index form, that is 2 raised to the power of what? 4. So now so we have this to be 2 raised to the power of x equals to 2 raised to the power of 4. Now, since we have same base, so you can equate the powers. So therefore, x equals to 4. Okay, so that is the answer to the problem. All right, so if you have learned one or two things, I want you to like, share, and subscribe to this channel if you have not done so. And don't forget to always invite your friends, okay? So we're going to meet in another class. Thank you for watching. Bye-bye.